Hey everyone, how are we doing? It is office hours. I see we got some great questions to start. Good to see you. We got like 10 people watching. Wow, that's awesome. In a 1992 article in the Journal of American Medical Association, researchers reported that a more accurate average body temperature for adults is 98.2, not 98.7, with a standard deviation of 0.7. Continue to assume that a normal model is appropriate with a normal distribution. Let's start drawing this out. Tiffany, great questions to start. Now, we mentioned this yesterday. The first thing we do, this is Canvas content quiz number 3 right here. The first thing we do whenever we get a normal distribution is we draw it. Make sure to draw it. And this is stuff for next week. Big stuff right here. Let's go check it out. 1 second right here while I fix the screen. I had to change it a little bit last night. There we go. Okay, 2 seconds. Woo! Just destroying everything. Fixing, changing. There we go. Look at that, all fixed up. Good to go, good to go. I should lock that in place. Locked. There we go. Maybe I should lock my other screen views. Locked. There we go. So let's start talking about this right here. This is Canvas content number 3 right here, or I believe it's Canvas content number 3. That is correct. And this is the temperatures for people, according to a new study, are normally distributed. So what am I going to start drawing right here? What am I going to start drawing, and what does this mean? What am I going to start drawing? When you write this capital N, that's the shape, the first number you give right here, I don't like that it's showing that. I'm just going to make that just appear. The capital N right here is the shape, and then the first number you see right here is the mean of the distribution, and the second number you see is the standard deviation. Those are just notations, mu and sigma for mean and standard deviation. So I want you to think what I'm going to start drawing right here. What am I going to start drawing immediately when I start writing this right here? This is just the general notation. Can we move this away? Move this over here. This is just the general notation, as in what the first number we put in is always the mean. So there's the mean. And then the second number we put in is always the standard deviation. And we're going to see this down here in a moment. And then the capital N stands for the shape. So what am I going to start drawing? This is material we haven't done in class yet. And it's a very tough chapter. And when you see this notation, what should you start drawing at first right here? I think we're live, right? We're currently live, right? If you are watching this live right now, please say hey in the chat. Live right now. Oh, we are live. There we go. Here in the background. Say hey in the chat if you're here right now. And what are we going to draw? We can do some visualization 3. You got it. Hey, good to see everyone. They do change. You are correct. They do change via each person. So these will be different. What are we going to start doing right here? Let's see if Mubot can give out some points. Mubot, you in the chat? Give out some points. Mubot is in the chat. He's always in the chat. So what are we going to start doing right here? When we see normally distributed, we're going to draw the normal curve. When we see normally distributed, we're going to draw the normal curve. Very important right there. We are going to then put at the center of the curve the mean. And then we're going to go up and down the standard deviations, which will always be some sort of constant amount. We'll go up 3 standard deviations. That's a poor 3 standard deviations. 1, 2, 3. 1, 2, 3. So we're going to go up and down 3 standard deviations. I can't tell that symbol. The one on the right. This right here, I'll write below them. This is mu, which is true mean. And this is sigma, which is true standard deviation. So true mean for like a population, and true standard deviation. Great questions. 50 points right there. Thank you for the questions. So that's not this. It is standard deviation. It's sigma. Here, I'll try to draw it a little bit better. Make it look a little bit better right here. It looks like this right here. That's about the best I can draw it. That is a sigma for true standard deviation. A Greek letter sigma for true standard deviation right there. And the sigma, I did the wrong color highlighting. The sigma is going to be the amount we go up and down each time we go up and down a certain amount on this curve. So the mean on the curve needs to go at the very center, 98.2. And then the standard deviation is the amount we go up each time. So think about this. We're going to go up 0.7 right here, 0.7, 0.7. And down here, we're going to go down 0.7, 0.7, 0.7. So what is Brian going to write in this space right here? What number is Brian going to write? If you're following along, yeah, the sum you got it right there. Great answer, Sophie, right there. Yep, we're doing this as the lowercase sigma standard deviation. Correct. So what is Brian going to write under that space right there for 1 standard deviation above? What is Brian going to write for one standard deviation above the mean. One standard deviation above the mean would be where? One standard deviation above the mean would be what? Like, what is the value of that? This is a very good start to chapter 5. Think about how we're going to use these numbers right here. 98.9. Great job, Tiffany, right there. You are correct. It's 98.9. We're just adding one standard deviation to it. So you can see where we're doing the adding there. That's 98.9. This is 99.6. And that's 100.3, just off the screen, just barely. Let's try to do a little better job on that. 100.3. So that is where we have it right there. Now we're going to go down. Please tell me if I make a math error. It is possible. And now we're just going to go down standard deviations here to 97.5, 96.8, and 96.1. How does the math look other than Brian's handwriting? And we don't need z-scores yet. Here's the thing. Great answer, Sophie, right there for another 50 points. Z-scores can be added to this, and a z-score is just how many standard deviations above or below the mean something is. So if your friend told you, I generally have a very high temperature, like generally my temperature is pretty high, I am one standard deviation above the mean, what is your friend's temperature? If your friend had a z-score of 1, what is your friend's temperature? If your friend says, I am one standard deviation above the mean, and these are all z-scores right here. Z-scores are how many standard deviations above or below the mean something is. If your friend said to you, I have a z-score of 1, you would know their temperature is what? You'd be like, oh, you've got this temperature because they're one standard deviation above the mean. Great job, Sophie, right there. You're right. And so z-scores can tell us instantaneously if something is an outlier. Something is an outlier if it is more than or outside of 2 or -2 z-scores. So these are things up here that are outliers, and we've done a great review. We're going to do, oh my gosh, I cannot write ever. Outliers. I think my handwriting has gotten worse as I've gotten older. Probably how it works. Those are outliers right there, things that are outside of -2 or +2 on the z-scores, and they're more extreme outliers if they're outside of 3 or -3. So with this right here, the question is, what percent of observations, let's look right here, is between a z-score, the middle 60% it says, let's check this out. We're going to erase some of this because we've already done the drawings right here. Make sure to practice this, know how to draw it, it's great practice. It says that the middle 60%, hearing weird noises outside, are between a z-score of -8.42 and 0.842. This is where 60% of the data is at. So if 60% of the data is in here, how much total, and my graphic might not look perfect, but just go with it. How much total is outside? I'll draw it here in pink. How much total is outside? If 60% of the data is inside of here, what is the total outside? 60% is shaded in. That's what it's telling us. 60% is shaded in. So you could also find, not for this one, normal curve does not have degrees of freedom. The t, the chi-squared, and the f, and a few others have degrees of freedom. T, chi-squared, and f have degrees of freedom. Normal curve is just one curve no matter what the data is. And Tiffany, you are correct. It's 40%, which means that there would be 20% of the data here and 20% of the data here. Now the question asks, let's see what the question says. It says, is between what is the 80th percentile of body temperatures? So the 80th percentile of body temperatures, I want you to think about this, is if you go and add up the data, when you get to here, you would be at 80% because you would go through the 20%. If you added it up this way, you would get to 80% right here. Tell me what you know right here. The 80th percentile of body temperatures has a what? This is such a good question. The 80th percentile of body temperatures has a what? The 80th percentile of body temperatures has a what? The 80th percentile of body temperatures has a what? I don't think you can, Sophie. Good question right there. Good question, good question. The 80th percentile of body temperatures, which is right here, has a what? What do you know about it? The 80th percentile of body temperatures has a what? Now let's use that information to find out what the temperature is. The 80th percentile of body temperatures has a what? Close, Tiffany, but not quite, not quite. You're on the right track. What is this information down here? What is this 0.842? The 0.842 is the what, though? You're close. The 80th percentile body temperatures has a what of 0.842? Not quite statistically significant. Well, just think about this information down here. The 80th percentile of body temperatures has a what? Once again, this is the harder chapter. This is where we need to practice. Be like, oh, the 80th percentile of body temperatures has a... It's above the normal. You are correct. And what does this 0.842 represent? That 0.842 is a what? This 0.842 is a what for the person? This is a harder question. This is probably one of the hardest ones that could be on the test related to this. This 0.842 is a what? You are correct. You're getting it because it's a z-score. That was going to be my next question. It is a z-score, so these people are 0.842 standard deviations above the mean. Think about how we can write that out. If somebody here is 0.842 standard deviations above the mean, that means we need to take the mean, which is 98.2, and we need to add to it 0.842 standard deviations. Now, a standard deviation is going to be 0.7, because remember, that's the distances we were going up right here. So that's how far above the mean they are. So they have a z-score of this. Now, think about this. When you solve this, your answer should be a little bit less than what? Whatever number you get right here. And I'm not going to put the answer in the chat, and so don't. But your answer should be a little bit less than this. And if you're getting a little bit less than this, you probably did it correctly. When you solve this, your answer should be a little bit less than what? Just look at the graphic and be like, oh, these are the temperatures. Here's the z-score. And this z-score goes to right here. So your answer should be a little bit less than what? So just think visually. It's like, okay, when I solve this, my answer is going to be a little bit less than this. What will your answer be a little bit less than? This is a very tough question. And great job, Catherine, everybody. Great answers. Your answer should be a little bit less than... not just great answer, Tiffany, right there. 99, yes, but also 98.9. Your answer will be a little bit less than 98.9 because 98.9 is a z-score of 1. Might be right, might be right. I can't say. But look at how we do this right here. We're taking the z-score and then we're multiplying it by the standard deviation to say how many standard deviations something is above or below the mean. That's what this z-score represents. And then we found that this is the 80th percentile. Does that make sense that this is the 80th percentile because 80% of people have a body temperature less than this, and then we found the z-score right here, and then we would know that we can turn the z-score back into a number right here. This is a tough question, and frankly, this question alone, this is about 70% of the material in Chapter 5. So if you don't understand this question yet, don't worry. We will be covering this more in depth in class. If you're starting to get it a little bit, you are way on track. I'm having technical issues, John, for Visual System 3 after I enter a variable into my Y. It won't let me enter any variables into the X. Any idea what's going on? Can you send me a screenshot of that, especially on Discord? If you can send me or email me a screenshot, I might be able to figure it out. But send me a screenshot as quickly as possible, and then I'll start looking into it. I think, what was the next question right here? Someone else had another one, but send me a screenshot. I'll try to figure out what's going on with that. We got a person installing Jump already. People want to do a talk through on Visualization 3. I'll tell you what, I can do we did a walkthrough of it yesterday. What do you want to do a walkthrough on for Viz 3? Should we do the box plots or should we do contingency tables? What chapter deals with hypothesis testing? Chapters 15 through 18, I believe. That's the end of the class. Yay, hypothesis testing. What should we do? Let's hop over to the main screen. It is open time. We can do some visualization here. A test is given to students and the mean is 70, standard deviation is 6. If Jerry has a score of 62, this is a great question too. So let's see right here. Let me copy the question. I'm going to change it slightly. Okay, ready? So, oh my gosh, I cannot write. Okay. Good test question right here. I think this is an easier one, but let's solve it. Let's look at another Canvas content. Must be behind what is the z-score? New topics that we haven't covered yet. Let's mention Kayla here. What is a z-score? These are new things we haven't covered yet. So sometimes we do things a little bit ahead. You never know. Let's go check it out. And Kayla, if you have any questions, what is the z-score is a great question. Let's go look at it here. So we really want to know what is a z-score. A z-score lets us know if something is above or below the mean. So when we think about this, z-scores should be used when the data looks what? Because we're using here the standard deviation. So this is review now. We're using here the standard deviation, and we're using the mean. So z-scores should be used when data looks what? No proofs. Oh, no proofs at all. Ooh, don't ask me to do those. You could, but I might be like, I don't do those. Z-scores should be used when the data looks what? Normal. Kayla, 100 points. You're 100% right. You got it. Great job, Kayla. Yep. Z-scores should be used when the data is normal. There you go. So let's go ahead and put the mean right here of 85. Notice how we're just taking the mean, putting the mean of 85. We can write this normally distributed with a mean and a standard deviation. And so we just plug into here the numbers for the mean, which is 85, and the standard deviation, which is 10. Now, the standard deviation is going to be the units we go up every time we go up a certain width on this graphic. So when we go up here, we're just going up to 95, up to 105. Ooh, this is an interesting graphic. And up here to 115. Notice I'm just going up 10 each time because of this right here. The distance marked right here is a distance of 10 because that is the standard deviation. We're going to do the same sort of thing by going down right here. And what is the first number I'm going to write right here? Who knows the first number Brian's going to put right there? So degrees of freedom is, it's used for certain things like the t, the chi-squared, and the f, because those require degrees of freedom based on the distributions, such as when we calculate the mean, we need 1 degree of freedom to calculate the mean. It's eaten up by calculating the mean because one value has to be constant. I could go into some theory stuff on that, but if you have 5 numbers, one number has to be locked because 4 numbers are basically free choices. So you have 4 degrees of freedom, 1 degree of freedom is eaten up by the mean, and the same thing works if you have ANOVAs and stuff, little advanced stuff right there. If you have like 4 groups, you'll have a global mean, and you'll have a mean for each group. So I think you're going to lose 5 degrees of freedom when you do the ANOVA on that. So and then you'll have the denominator, you'll have the numerator degrees of freedom in an F. And so yeah, that's a little more advanced. Don't worry about that. Don't worry about that. What is in this blank right here? What is in this? Who knows what number would go right here? Brian's filling out his graphic. Sophie's asking some really great questions. What would go right here? Sophie's got some really great knowledge. What would go in this blank right here? 75. You got it. So what are we doing? We're just drawing the normal curve, and I want to state this, that you can always use something to check your work. Draw out these curves, practice. Great job, Kayla, right there, and Tiffany, another 50 points in the chat. You can go to the David M. Lane applet. So I'm going to bring up the David M. Lane applet right here, and we can put this information in pretty quickly. Now, one thing I always do after drawing my normal curve is I always draw below it the whats. And let's talk about what these are, because this is the question. You can always put below it's the whats. I would always do this. I promise you, a lot of the people I see who make A's when we give tests in person, they're drawing this below it. I see their graphics, and they draw this out for themselves. And then the answer is pretty clear for what the problem is. What did Brian put below this? And let's talk about what these are. What did Brian put below this graphic? He put all the whats for this right here. What did we put below this graphic? So think about what we put below this graphic. Brian put every or all, there's more Z's. What's below the graphic now? The Z-scores. Yep, these are the Z-scores. Because 95 is 1 standard deviation above the mean. Does that make sense? 105 is 2 standard deviations above the mean. Now, 65 is what? Just think about what 65 is. When you see -2, it's because 65 is what? -2 is there because 65 is what? 65 is what? So because -2 is below it, 65 is actually what right now? 2, and you're right there, Kayla, excellent work. It's 2 standard deviations below the mean. So the way we can do this is we can use a formula right here to do the following. We can go observation, I'm going to change colors to a purple pen. We can go here, observation minus the mean divided by the standard deviation equals to the Z-score. Now, I want you to think about this formula for a second. The top part of the formula is just a distance something is away, and then we're turning it into how many standard deviations. So a z-score is literally how many standard deviations above or below the mean something is. We find out how far it is away, and this thing is 20 away. Does everyone see right here? This is a distance of 20, and 20 is what? 20 is actually what? When you think about 20, 20 is, and it's negative 20 to be exact, it's negative 20, and negative 20 is below, but it's what? Negative 20 is 2 whats? Because that's what we're doing by taking negative 20 up here and dividing it by this. Negative 20 means it's 2 standard deviations. What? We got to fight that instinct, Sophie. Negative 20 means this observation is what? Means it is what? You're on the right. Yeah, it's 2 standard deviations below the mean. Does that make sense? If your friend is super excited, yeah, let's do one where we get a decimal answer. Let's change these numbers. So let's change the numbers right here. This changes the context of the problem. I'm not going to give you the answer. I'm not going to give you the answer. Okay, so this is practicing z-scores right here. Oh my gosh. Don't do that. Okay, let's change this right here to a test with a mean of 72 and a standard deviation of 4. And I want to know what Jerry's z-score is. So now we have a mean of 72. Take a moment right here. Let's put on a little moment music right here. Take a moment if you're following along. This is great practice. See if you could solve this test question. I'll draw it out right here. I want you to figure it out while I'm working on this. So we're going to get a decimal answer right here. See if you can take a moment. I think it is a decimal answer. I'm working it in my brain right now. So I'm going to draw some hints right here. We're always going to draw our normal curve on here. The z-score was -2 on the last one. So what is the z-score on this one? So take your numbers. Here, I'll give you a hint. I'm going to draw on this. Jerry made a 75. That's the y. That's the observation. The mean right here is 75. And the standard deviation... Oh, that's... Standard deviation is 4. And the mean is 72. So what right here... Oh, we won't do critical values. We will be doing those in a little bit. No worries, Sophie. So what is Jerry's z-score? What is Jerry's z-score? These are the actual scores people made. The numbers below in red are the z-scores. So this will give you hints while you're trying to solve it. Like, you'll kind of get a guesstimate right here. Can you tell me what Jerry's z-score is? Can you tell me what Jerry's z-score is? So you want to take the observation. I'll keep writing it through here. You want to take his observation. You got a 65. You want to subtract the mean. So how far is he away from the mean? He's 7 below the mean. And then you want to divide by the standard deviation. And then that is a z-score of what? What is the z-score? Yep, discrete continuous distributions, yep. What is this a z-score of right here? You are. And why do you get a negative number? You do get a negative number, and why are you getting a negative number? That is very true. Good guess there, Harry. Check it. Try the math. You are correct. It's negative 1.75. I hate how the color change works right here. Microsoft Word, you need to fix yourself. And I want you to look at the above graphic. Take a look at the above graphic right here. Why is it, and great job, Haley, right there, another 20 points. Why is it negative 1.75? Why is it negative 1.75? And then just explain to me, just talk to me. Well, because Jerry is this. Jerry is, explain to me what the z-score means. Jerry is this. So explain to me what this means right here, that Jerry has a z-score of negative 1.75. Be like, oh, because Jerry is, and then think why it's negative, because this right here. So, and then we're going to do a few more questions on this to make sure we understand what a z-score is. Why is it negative? He's below the average. Exactly. He's below the mean. He's 1.75 standard deviations below the mean. Let's look at the heights of guys right here. So we're just going to switch topics real briefly right here to the heights of guys. And the heights of guys is normally distributed with a mean of 69 inches and a standard deviation of 3. My height is a z-score of 2. How tall is Brian? My height is a z-score of 2. How tall is Brian? So see if you can solve this right now while I'm working it out. I haven't shown you the answer yet, but my height is a z-score of 2. How tall is Brian? My height is a z-score of 2. How tall is Brian? Oh, should call me out on this. My height is a z-score of 2. How tall is Brian? It might be. Might be. Double check it. Tiffany, that might be right. Screenshot from Jump. Oh, okay, we'll look at that next, Jillian. You got it. You got it, Jillian. You got it. My height is a z-score of 2. How tall is Brian? My height is a z-score of 2. How tall is Brian? And just think about what this means to say, oh, you are correct, Tiffany. Yep. And why is that? Because 75 is what? 75 is 2 standard deviations above the mean. So you have to go here and go plus 3, and that means it's 2 standard deviations above the mean. So whenever you hear a z-score, you're just like, oh, that's just how many standard deviations something is above or below the mean. So my height is 75 inches. I'm 6 inches taller than the mean. I'm 2. You just times this by 2 and add it to the mean because you're doing 2 standard deviations. Tiffany, great job right there. And that's where you can take the value. Kayla, great job. 100 points, Tiffany and Kayla. We'll be doing this in class. And yeah, Tiffany right there, definitely earning those 100 points, showing the equation. See, sometimes this is where we just do teamwork right here. Good to see you here, Trace. Can you go over the baseball league question in chapter 4 homework? You bet. We can do that here next. We're going to look at Jillian's problem next. But this has been a really good talk on z-scores. Brian's friend John in high school was 4'11". What is Brian's friend's? And I want you to use the cheat sheet on the screen. Brian's friend was 4'11". Can you tell me Brian's friend's z-score? 4'11 is 59 inches, so we would say the y observation is equal to 59 inches. So we would do observation minus the mean of the distribution over the standard deviation to get the z-score. Brian's friend had a z-score of what? Brian's friend was 4'11, so Brian's friend has a z-score of what? Definitely a big outlier right here. My roommate after college was he would say he was 5'2" in high school. Oh yeah, the chi-squared, yeah. We'll be doing that way later on. So Brian's friend was 4'11. So take a moment, see if you can figure it out. Brian's friend was 4'11. What was their z-score? Tiffany, amazing work. You're getting it. And that means he's 3.333 standard deviations below the mean. So you go here and you go 59 minus 69, which is 10. You'll get here 10 over 3, or negative 10, excuse me, because he is below the mean. And you will get here a z-score of negative 3.33333. And I want to point something out. If you do your drawing, then you should see right here that they would land right about there, which is negative 3.333. Is this starting to make some more sense? He's negative 3.3, or he's 3.333 standard deviations below the mean. Make sure you use negative or positive. Now, if Brian had a friend like my friend Brian, who was my roommate, who was 5'9", Brian's roommate would have a z-score of what? Last question here, then we're going to do I'm going to look at Jillian's thing. Brian's roommate was 5'9", 69 inches tall. Brian's roommate has a z-score of what? Brian's roommate, who was 5'9", 69 inches, had a z-score of what? Brian's roommate. Oh, Trace coming to visit us for the first time for this semester. So good to see you, Trace. Brian's roommate had a z-score of what? Brian's roommate was 69 inches tall. Brian's roommate had a z-score of what? And if you plug in the numbers, you can solve it. So now we would say we are observing someone who is 69 inches tall. So y is the observation. And we would subtract that from the mean. And Brian's roommate has a z-score of what? And just think what it means if you're 0. You got it, Kayla. And why does Brian's roommate have a z-score of 0? Because why? Just think about why something would have a z-score of 0. So the graphic helps us. to figure out the answer. And why would they have a z-score of 0? Like, you're like, wait, z-score of 0, what does that mean? Well, then the individual or the item we're looking at is right where. So if something has a z-score of 0, it's like, oh, well, then that's right there. That's right there on this. So because the individual has a z-score of 0, this is for quantitative distributions right here. He is exactly average. He's totally average. He's not above or below the mean, totally average right here. You can see here my other friend was very much below the mean. It might have been positive. I can't remember. Sorry, Tiffany. I can't remember. He's exactly average is the right answer right here. And these, we can use this as a cumulative or a frequency. If we do that, we can use it for the CDF and PDF, depending on which sort of problems we do. Great questions. We're going to look at Jillian's problem right here. Let's take a moment. So that is a really good review of z-scores. If you were here for just that 15 minutes, you're probably getting ahead on z-scores, which is next week. So once again, thank you so much for being here for office hours. The chocolate kaboom candy manufactures many types of different normal distribution of with a mean of 452 and a standard deviation of 17. Yep, I can tell you if it's positive or negative. I'll tell you that much. Let me look at Jillian's problem in the email. Keep posting the question. I'll tell you if it's positive or negative. Here we go. I'm looking at Jillian's thing. Oh, you might... No, you should be able to select a second one. I haven't rolled jump. It won't let me click off of the first variable I click on. You might want to reset. It should allow you... Try clicking the Xbox, Jillian. You might need to show me on Discord. It might be like a time to like reset the computer. I'll show in the background right here. Just general generic picture jump right here. What up, Colin? So good to see you here. You decided to buy a toggle box and weigh it. Your box weighs 474. Calculate the z-score. Should be a positive z-score. And why is it a positive z-score, Tiffany? Why would that be a positive z-score? Why can I tell you instantaneously that that z-score must be positive? See if you can answer that in the chat for 50 points. Colin, good to see you. We're throwing some 50 points for random Colin right here. Why would that be a positive z-score? Why would that be positive? Because it's above the mean. Exactly. So you instantaneously know that that's above the mean. Yeah, Kayla, you're doing great. And once again, when we do this in class, it's going to be a review now. And you're like, 15 minutes of office hours. I've already got it down a little bit. So you'll be in class reviewing the topic, which is what we like to do. So let's take a look right here. Just looking at the screenshot. When you click on something, you want to click the other variable. You got social political right here. If you wanted something like broken bone, you could click on this and then click the X factor. If it's not letting you click stuff, that might be some sort of error. Maybe try resetting computer. Or we might have to hop on a Discord call and we can look at it. But if it's having an error, I don't know. I think we had chapter 4, which we haven't done yet. I'm gonna toss my pen on the ground. On the ground on the desk. Let's go back to the main screen. Okay, we got some chapter 4. Chapter 4 time. Gosh, I love the Stream Deck XL. It's the best thing ever. Everyone's like, Stream Deck's not worth it. Let's see. So Jillian, I hope you're here. Might want to reset, or I might have to join a call on Discord to look and see what the problem is. Okay. There we go right there. Got that. And let's go look at some My Pearson, chapter 4. If you have questions, put them in the chat. We only have My Pearson 4. We did Viz 3 yesterday. We can go back and do Viz 3. I'll probably do like a part of it if people say like, hey, could you really go over some box plots again or some contingency tables? We did Viz 3 yesterday. So I'm doing new stuff right here if we can do new stuff. Always up for that new stuff. But if you have an old thing that you like, then you can also say like, hey, you know, that would really help. The question was, do you mind taking a look at my email? Yeah, I'll take a look at it next here after this. Oh, in ours it says Greek life, and I'm unsure if that's... Yep, just make sure you have the right variables, Kayla. If you're concerned, send me an email and say like, hey, does this look correct? And I can take a look. I'm going to do the question here. I finished the part of the baseball question. I'm stuck on 2 and 3. So it's the baseball question. Thank you so much, Michael. Let's go look at that baseball question. I think you said chapter 4 quiz. I'm going to get that up and going. Let's see. Oh my gosh. Holy mackerel. There's a lot of questions for this quiz. So I'm going to show you in the background right here while I search for the question. You can just see how many questions there are. Here we go. The sugar question. Good stuff right there. Turn this on right here. Okay. Baseball question. See, I can't see it on the screen anymore. Oh, wait. Is this it? Wait. How's the question start again, Michael? Let me see what Michael said the start of the question is. Michael said, can you go over the baseball league question in chapter 4? Is this baseball league? No, it's regions. Baseball league question. miles per gallon. Baseball league. Here we go with the baseball league question. Let's do this. I think this is it. Is this the question, Michael? Is this the question? It's on the homework too, it looks like. So we should put homework and quiz on this. But does this look like the right question to you? Yes, good, or no? Not at all. It's in the homework, but is this the same version of it? I could go to the homework, but is this it? I know it's in the homework, but is this it right here? As soon as you get a homework question in the quiz, because there's like they repeat. Awesome. Let's go check this out. This is on the homework and the quiz. So good stuff right here. Let's go check this out. This is homework and quiz question for chapter 4. So a very valuable question to do because it could appear in your homework and your quiz. So the first thing you notice right here is we are comparing baseball leagues and we've got a data frame right here. Now you could use this data frame to kind of figure out what's going on because we see the highest point in League B is 4.93. You know, we could probably figure it out without graphing it. Look here. We got some lowest points. We got some outliers. A little bit tough to tell what's going on. I think I can tell what the answer is. I've got some good guesstimates, but here's how we're going to do this. We're going to use jump. Question we ever have to choose between population mean versus sample? We might have to, just depending on what kind of question we're doing. Good question right there. We might have to. We're going to copy this data. So here's how to get 100 on it every time is to do it in jump, just like your visualization assignment. So we're going to copy the data right here, copy to clipboard. Try to do this slowly so everyone can see. Now that we copied a clipboard right here, my chair's getting green screen a little bit. We're going to hit Control or Command C. Control or Command C. Now we click Done, and we go over to Jump. And inside of Jump, that's Excel. We go over to Jump, and inside of Jump, we go to File, New, Data Table. Very key right there. File, New, Data Table. File, New, Data Table. Under File, New, Data Table, make sure you go to Edit, Paste with Column Names. You might need to slow the video and watch this part very slowly. Edit, paste with column names. If you make a mistake, start over, because this is where you can paste incorrectly and you need to start over. So please make sure you paste with column names and you see that these are blue. If they're not blue, please restart and make sure you paste with column names. If you paste normally, it won't do it correctly. These need to be blue. Sorry. It's the most common error. So now we're going to go to tables and then we're going to go to stack. We're going to go to tables and we're going to go to stack. Once we go to table stack, we're going to double click average runs per game and average runs per game till they're both over here. So make sure you double click both of them and have them both right over here. And this will stack both of them. We can do horse race. You got definitely Marjorie right there. You got it. And there we go. We've got our table and we've got our data and good to go. I think we're good. And here's the label. And then there's the data. Awesome. This is the league right here, the label, League A, League B, and then we have right here the other data. So these are the leagues, and these are the data. Let's go over here to Graph, just like your visualization number 3, and go to Graph and go to Graph Builder. I have to pause this video and slow it down a little bit, just to answer some of the big questions. Under Graph Builder, we're going to take the categorical variable, and we're going to put it down here under the X. The categorical variable will go on the X right here, and then the data, which is the amount of runs they're getting, is going to go over here on the Y label. Once we've done this right here, you see we can go to the box plot button and we've answered the question, where are the box plots? Now, what do you notice instantaneously about my box plots? What is the big takeaway? And this might be yours. I don't know if every one of these is the same, and you should hit done when you make these graphics. What do you notice instantaneously about my box plots? Which is going to answer a lot of which is the right graphic. What do you notice instantaneously about my box plots? There are whats, or there lack whats. So what do you notice instantaneously about these box plots, which will really help with answering the questions? Because you can look at the box plots and be like, oh, kind of makes it obvious to see there's no outliers. Boom. Got it. So we're good to go because we see there's no outliers, and that automatically tells us which one is the answer because there's no outliers. This point up here is not an outlier. This point down here is not an outlier. That point up there is not an outlier. And that point down there is definitely not an outlier. So it gives you the 5-number summary, which is something we covered today. Know how to calculate the IQR and understand that the range is always up to the highest and lowest point. Big things to know from today. So the distribution of runs per game is blank in League A. League A. Now this is the tough part. This is where I'm going to get mad at my Pearson, hopefully. Hopefully not. They're going to say it's skewed. And I think they're going to say it's skewed to the right because of this tail on the high side. Do you see this pull right here on the tail? They're going to say that that's skewed to the right. So you're basically getting the right answer right here, unless I get it wrong. They're going to say this is skewed to the right because of this pull. But this distribution right here looks more what? So Michael, how does this distribution right here look? This distribution right here looks a lot more what than this one, which has a pull to the right side on the tail. The whisker can sometimes denote tail or like skew. So this one over here looks a lot more what for League B, which you can see it over here. You can see the skew a little bit on that, pull to the right side. And then this one looks a lot more symmetric. Yep. So the distribution of runs per game is in League A is skewed to the right a little bit. And in League B, it's roughly symmetric. So it's kind of symmetric. Great job, Kaylin, everybody. Michael, following along excellently. Disappear here so we can see it. The typical average runs scored per game in League A, well, that's pretty obvious, is what? We're seeing right here the medians. So we're comparing the median, the 50th percentile here, and the 50th percentile here. So League A is going to be what? And once again, try to figure out the answer before looking at it and be like, oh, the median is right to the high. Yep. Oh, great job, Kayla, right there. Some 20 points. Remember, right to the high, left to the low, whatever way the tail goes. And that's more of a tail right there. So it's going to be higher League A. The typical run scored in League A right there is higher than League B, while the variation in runs scored per League A is blank to League B. Now, variation is going to be the IQR. Which of these has a bigger IQR, League A or League B? IQR is the box of the box plot. This right here is the IQR. Let's draw on it and make it nice and pretty right here. So we are going to simply draw the IQR on this so we can see. IQR is a measure of spread, and you can see it in the box plot right here, and it's pretty obvious that the variation in League A is what compared to League B? The variation in League A is what to League B right here by comparing IQRs. Q3, let's draw on that. Q3 is the upper end of the box, Q3 right there, Q1 right there. The distance is the IQR. Just subtract those numbers like you would min and max. And we could finish the 5-number summary as practice to make sure we know where the 5-number summary is at. If you do have an outlier, it will be the min and the max. So watch out. That's the most common mistake, and that's the median right there, also known as Q2. And it is greater than, great job right there. There is a larger IQR on Group A. The IQR is greater. So the variation scored in runs is greater in League A is greater than League B. We should have everything correct, I hope. Great job, everyone. 20 points, following along perfectly. Love it. That's what I want to see in the chat. I love when you're following along. I usually ask something 2 or 3 times, so try to answer in the chat, see if you're getting it. Great job. The two teams playing for the championship, League A, Team 1, and League B, Team 1, both were at the top of their respective leagues. Did either team score an unusual amount of points? And the question then becomes, is this an outlier and is this an outlier? And the answer is most definitely 2-letter word. Did either team at the top of their leagues score an unusual amount of points on average during the season? And just think about what's going on. It's not one of those. So did either team score an unusual amount of points by looking at these box plots? And hint, it doesn't look like this. They're here and they're here. Now they're high. This top of the whisker is the highest point, but it's not an outlier, which is unusual. We chose the one with no outliers because remember we didn't jump right here. So are either of these teams unusual? I mean, they're high. There's like, well, that's a lot of points, but that's not really that unusual because they're above the mean, but not really far. They're above the median, but not really far above the median. Neither team scored an unusually large amount of runs. Both teams scored fewer runs than the upper fence, and the upper fence is where outliers begin. We went over this a lot in class today, where the upper fences were. If you want, definitely check out a review of class today where we were calculating the upper fence and where it would be at. So we did this in class today, and we calculated the upper fence here to be at 5 and the lower fence to be at -3, and that's where outliers begin. So check out either the speed run or today's class to calculate where the fences are at, and the fences are where outliers begin. That's so they're talking about where an outlier would begin. We should get it. Oh, wait, what? Check answer. There we go. Woo! Love it. Not today, my Pearson. Not today. I think we have another one. Can we do the horse speeds after this? You bet. Let's do it. A little chill music right here. One more coffee. I can't go to 3 cups a day. Just be wrong. You're welcome, Michael. Great job. Great question. Good review. Always think about what am I learning with these things. For Viz 3, box plot, does the categorical go in the X? You got it. In the quantitative in the Y? Yep. You technically could switch them, and I'd probably give you full credit. Like, if you ever think the graders are mean to you, just email me. I want more coffee. Yes, get some more coffee. So, Catherine, if you ever like, I don't think the graders should have taken off points, you can email me. I gave someone points back last night. But you don't always get points back. So I might say, yes, the grader is correct. Or I might say, oh my gosh, grader, what are you doing? Sometimes I'm the grader and I say, oh my gosh, grader, what did you do? And then I'm like, oh yeah, I graded that. Oops. So email me if you ever see an error or you think it's an error. I'm more than happy to take a look. And sometimes I disagree with the graders. Well, I like that question a lot. This is the Ogive, I think. I think we're gonna do the horse one with the Ogive. Such a weird thing. Let's take a look at the horse problem here. Chapter 4 quiz. What's it called? An Ogive? Ogive. Let's look at the Ogive and explain it. Let's check this out. This is a tough one also. We were doing some of the toughest ones today right here. So if you get this one, once you know how to read it, it's not that bad. Let's try to read it. I forget how to take the sample and jump. Oh no! Go to, I'll show you in a second here. I forget too. Okay. So what the Ogive is giving you is it's giving you the percentage at certain points. If I were to go right here, let's take a screenshot of it. Brian is telling you that the what is where right now. Let's go zoom in on this. I'm going to start drawing on this to make it more clear. Okay. So if I were to go right here, Brian is trying to tell you where the what is at right now. Brian is trying to tell you where the what is at. 50% is below this point right here. Whatever that is, and we could trace it downward. So Brian is trying to tell you where the what is at. I think that's where it's at. Brian is trying to tell you, and it's right about, I gotta be careful, I gotta use a thinner pen. Brian is trying to tell you where the what is at. The median. Does that make sense? Great job right there, Marjorie. You are correct. Another 50 points. Big points today, as always. Tables and subset. Kayla, 100 points. Thank you so much. My brain just wasn't working right there. Kayla earned everyone 100 points. Thank you for helping out. Vols help Vols. I really appreciate that. Sometimes my brain just doesn't remember the answer. Table subset. You are right on the top left, like third button over. Great job, Kayla. Thank you so much. 100 points for the class. So when we do this right here, can you guess what the median is? Now, there's like a plus or minus of like a tenth in here. But can anyone give me a guess of what the median is? Can anyone like be like, you know, the median looks to be about this for this data? Be like, median's about, what do you think the median's about? I went over and traced where the median's at. It's at the 50th percentile. I traced down. And where do you think the median's at? Yeah, Sophie, anytime. Say thank you, Kayla. Kayla right there. Awesome job, Kayla. I always appreciate 35.9. I think you're right? It's either going to be like 35.9 or 35.8. I think 35.9. We're going to do 35.9. If it gets mad at us, I'm just going to get mad at my Pearson. So that's about 35.9. And this is what we're doing for any points in this. This is how to read the Ogive. So when you read the Ogive right here, you're just going to go over from the percentile over here and trace down. So you could find things like Q1. If you want to find Q1, you have to trace over where 25% is at. And Q1 is, oh, that's so nice. Oh my gosh. Who can tell me? I'm not going to show you. Who can tell me where Q1 would be at? Here's where Q1 is at. Here's where Q3 is at. What is Q1 at? Go ahead and tell me what Q1 is at. Take a moment right here. We'll throw another 20 points. Marjorie, great answers today. Awesome work. Where is Q1 at? Like, what is Q1 at? Just look at the graphic. I'll show you in a second right here. I'll show you how to get it. Where is Q1 at in this data? Like, Q1 would be at a winning speed of what? The winning speed for Q1 is what? 34. Kayla, excellent work reading these graphics perfectly right here. You are correct. That one looks to be pretty much exactly at 34 when you trace down. That one's right at 34. So that is where Q1 is at. We see where the median is at. If we do over here for Q3, I'm just bad at tracing stuff. When you trace down on this, not as bad as I thought it would go. This looks to be about, that's Q3 right there. This is about 36 point. I'm going to go 36.8 on that. There's a, really? I clicked the pen for once. My fault. 36.8 about. Change the size of it, of course. It's just trying to mess with me. Let's go ahead and take a look at the problem and see what we got right here for the problem. The problem says, what's the problem saying? Don't go away. The problem says the median winning speed, which we were just talking about, the median winning speed, and we'll zoom in here again. The median winning speed, which is right here, and we trace over, we said was 35.9. I think we'll do all right. So 35.9. So doing it this way, you can hardly get an exact. Yeah, and they have a plus or minus of like 0.1 in here. Just kind of look closely. Remember, we were doing the lower quartile next. So we went here and looked at the lower quartile, and we found that that's at 34. You're kind of just reading it off the graphic. So trace over and see if you make sure they're in the right spot. And then let's look at the next one. It says the upper quartile, which is Q3. We're going to trace over here, trace down like we just did. That was 36.8 by our estimates. Remember, just tracing over. So who can tell me the IQR? The IQR is not the range of the data. Oh, we got to do the range first. The range is going to be the maximum number minus the lowest number. So let's go look at our graphic again. The lowest number in this data set looks to be about what? The lowest number in this data set looks to be about what? And we'll highlight it over here. The lowest number in this data set looks to be about what? The highest number in this data set, I'm going to have to delete some stuff off this graphic. The highest number in this data set looks to be about what? The lowest number looks to be about what? The highest number looks to be about what? There's the lowest number highlighted in yellow. Here's the highest number highlighted in pink right there. And that higher number might be a little... I think I know what it is. Okay. The lowest number, 30.2. Great job right there. That's worth some 50 points. Great job, Kayla, right there. I agree. That's a great estimate, 30.2. And the highest number looks to be about what? We should be all right. We should get 100 on this. The highest number looks to be about what? If you had to estimate that highest number, what's that going to be? And great job. I think I know what that's going to be. Almost. It's obviously 37 something. Exactly what I'm thinking. So then the range is just going to be how far are these numbers apart? So the range is 7.4. That's the range of the data right there. So that's just the range of the data. It's a range of 7.4. I think we're doing all right. We'll cross our fingers. We're going to cross our fingers. Then we need to do the IQR. Can anyone show mathematically? See if you can take a moment right here and mathematically tell me the equation for the IQR. It's basically on the screen. We've already done the work, so we can get the IQR. What do you think the IQR is? And we could actually check our answers down below a little bit. Great job right there, Kayla. Excellent work. You are right. It is 2.8 because we're just doing Q3 minus Q1. The IQR is always a positive number. It's just the distance these numbers are away, Q3 and Q1. So 36.8 minus 34, and that's the IQR right there. Amazing work, Marjorie, Kayla. 50 points, combo team right there. So now when we look at this, we need to figure out... No, it's not that. This would have to have all the data right here on the 75th percentile. The ones we're really thinking about, probably a good way to distinguish between this one and these is the box of the box plot should be the what. The box of the box plot should be where the what is. The box of the box plot should be where the what is. If you look, that's right at 34. The box of the box plot is the IQR. And I think the IQR, so that's at 34, and then the top of it's at 36.8. I think this one's wrong. That goes 36, and then the max on this one is where? The max in this one's in the 40s. Oh, remember the maximum was not as high as 40? Let's go look at our graphic. The maximum was 37.6. Okay, so this graphic's wrong right here because it goes above 37.6. The two we're picking between are this one, which has an outlier, and this one, which does not have an outlier. So does this make sense? Like we are picking between this one here that has an outlier and this one that does not. So the big question becomes, is this point down here an outlier? So we have to go 1.5 IQRs below 34. Now, this is probably the hardest part of the problem to make sure you get right. It's a 50-50 shot, so we could just guess, but let's not do that. We're going to go, and we're going to take this IQR of 2.8, and we're going to times it by 1.5. This is the whole 1.5 IQRs we were talking about to figure out if something is an outlier. And then we're going to subtract that from 34. And you know what's very interesting? We just found where the what is. We just found where the what is. By taking Q1 and subtracting 1.5 IQRs, we just found where the lower what is. We just found where the lower what is. By doing this right here, we found where the lower what is. This number 29.8 is where our lower what is. Lower fence, Marjorie, great practice from day. That is the lower fence calculation. And 30 would be where to the lower fence. This is where the lower fence is at. I'm trying to show it right there visually. The lower fence is there, and 30 should be what to the lower fence? That's our lower fence at 29.8, saying outliers begin at 29.8. Below 29.8 is outliers. So 30 would be what? And this is going to give us the answer to this one. 30 would be what now? because we just figured out, we're like, okay, well, 30 is above the lower fence, so 30 is not an outlier.
Wow.
Because 30 would be above the lower fence. Does that make sense? The lower fence is down here at 29.8. 30, which is the minimum, we figured that out previously by figuring out the min and the max. So 30 is within the lower fence. Remember, we were figuring out what these numbers were, so we had to go step by step and say, okay, the lowest number is, it's not 30, it's 30.2. 30.2 is within the lower fence. And you could even check over here looking at this, and you should see it. That's at about 30.2. It's a little bit above 30, but 30.2 is within the lower fence, just barely, but that means it's not an outlier. Big stuff right there. The distribution of speeds is what? Right to the high, left to the low. What way does that tail go? Is it symmetric? Is it uniform? Right to the high, left to the low. What way does that tail go? Be careful. You could be tricked. Does it go right to the high, left to the low? Is it more symmetric, like this one? That one's roughly symmetric. That one's also a little bit weird. It is left skew because it goes to the left. The biggest problem people have is they just like flip it and they're like, oh, it's right skew. But remember, sometimes your number line is reversed when you flip it, but that is left skew because the tail goes to the left. So that is definitely left skew. The typical horse race has a speed of this. This is going to be the median because that's like what we expect. So whatever the median is, don't give me any points off here, my person. Most of the horse races were between the quantiles. So you're just basically repeating answers now. 36.8 is the other answer. Okay, let's cross our fingers here because we got that 0.1 margin of error. Boom, we got that 100. I don't know why I got scared. Left to the low, whatever way the tail goes. Got that 100. Don't make any mistakes here. It's easy to make mistakes. Even I make them sometimes. You'll see it every once in a while. I got a really fun question I want to do next. We're going to do one of the Brian's questions here. If you have a question, please put it in the chat. But we're going to do another Chapter 4 quiz question. Let's go check it out. I think a really fun one is it shows you the box plot, and you have to figure out what is the distribution from the box plot. I don't play these musics nearly enough. I just like them to chill to. To me, it's just nice, chill music. Just lets us relax. Saw a really good question. This one right here. Let's go take a look at it. Another Chapter 4 question on box plots and histograms. This one's a tricky one, but it's fun. So we have here different shapes of distributions, and I'd like you to look at this, and I'd like you to just tell me this one is a what distribution. Just look at this top one. This is a what distribution. We got here class 1. That is a what distribution. Just be like, boom, that's a unimodal something, and this is the important part of it. That is a unimodal what distribution? This is the easy one. That is a unimodal, and most importantly, it's much easier to see the shape in a histogram. We're going to look at the box plot that corresponds with it. And we want to know for class 1, one of these box plots is the right box plot. That is definitely unimodal, and it's definitely... It's quantitative because we're doing a quantitative thing right here. We're looking at number of students. We might have reported how many students came to each class. Yep. So it's definitely what? So it's a quantitative unimodal distribution, unimodal quantitative distribution, displaying one quantitative variable. We collect every day how many students come to class. Sad day when we only have 30 students, especially we can up to 100. But it's definitely like our last distribution to the low side. It's definitely what this. Definitely what this. It is skewed and it's left skewed. So check it out. Do you see the tail right here? That is a left skew distribution because the tail is pulled to the left. So this is a left skewed. These are more symmetric right here. These box plots are symmetric. This is not symmetric. That was the easy one. Now people get stuck because they say, wait a minute. This is a very what distribution. Think of one word. This is a good what distribution. It's symmetric, but the other word I would want to hear is that it's also this. It's like a bread box. This. It is symmetric. Great answers right there, Kayla, 20 points. This is symmetric. That distribution is symmetric. This one's not quite normal. We wouldn't say it's normal. It is symmetric. This one is symmetric. The bottom one's gonna be normal. This one is symmetric, but it's more uni. It's one form. It's one form. This one right here, distribution number 2 or class 2, has more of a uni something distribution. Not unimodal, like this one's unimodal. This one's unimodal. This one is... So this is unimodal. This has one modal area, like one peaked area, modal area of concentration of data. This has a modal area, like a concentration of data area. It's just left skew instead of symmetric. Oh, that's all right. I'm throwing you 100 points. If you say I don't know, I'm cool with that. Uniform, that's worth that 100 points right there. Uniform, one form, uniform. I'll drop hints. And if you say I don't know, that's a great answer. Shows you following along, and I appreciate it. So this is uniform symmetric. So I want you to think about this. If I take this distribution and I smash it down, I am increasing the what of it. If I take this distribution and I smash it down, I take the distribution and I smash it down so it becomes flatter, I'm increasing the what of the distribution by smashing down a distribution. By taking a distribution and smashing it down, just watch, boom, I'm increasing the what of the distribution. So from this one to this one, if you were to smash it down into the other, you're increasing the what of the data. Think of shape, center, spread. So you take the data, you smash it, you'd have a bigger what to the data. You take your data, you smash it, you're going to have a bigger what to your data. Your data is going to be more what. Because you're smashing it down. You say, here's my data, and it's going to be like, it's more what. So think shape, center, spread. One of those is changing. The shape's changing. More spread out. Exactly. It's more spread out. So remember, this is the left skew one. We just did this one earlier for that. This is not the answer to this one. This one has a much tighter concentration of data in the center. This one has a bigger spread to the middle 50%. Does that make sense, Marjorie and Kayla, right here, that we see right here a bigger spread to the middle 50% right here because it's more spread out, where when we get to class 3, this one's more concentrated in the center. It has a tighter concentration of the middle 50%, where this one up here has a greater spread to the middle 50%. So that's class 2, and class 3 by default now is the one with the tighter concentration, because it's more modal in that area, has a tighter peak, less spread, which the IQR is a measure of spread. And guess what? We just got another question correct. Is that making sense right here that the IQR is showing us a measure of the spread, where this one has a tighter spread right here to the middle 50%, i.e. this one is tighter around the middle 50%. This one has a greater spread to the middle 50%. This is great right here at the end of this because these are the answers in order. I don't know if yours will do that. It will randomize, but you can see right here the answers to the first one, left skew. The second one, a higher spread to the middle 50%. Still symmetric though. You can see the symmetry here. Box plots are not the best to look at shape. Histograms are going to give you a better idea because you can't always tell like the modality with box plots. Great stuff right there. Great question. I think it's open floor on questions. We've got another 28 minutes. You got questions. I've got answers. What are you working on? What questions do you want to know? We could do some more chapter 4. A lot of great chapter 4 today. We did a little chapter 5 today. It's time to get serious. Get serious. Work some statistics. Good stuff right here. Sports. If you have questions, let me know. It's open floor. I think Tiffany had a question about the email. I think I didn't get to that. Tiffany said, look at the email. We go, not too many emails today. Not too busy a day. Let me see here. Yes, Tiffany, this is looking good. Looks great. Give a good write-up. And you're good. One thing that's interesting about teaching is you get so many people who reach out to you who want to sell stuff to your students. Nope. Oh yeah, it looks great, Tiffany. If you saw, it looks great. Just emailed you back on that. I just looked, and luckily, like, I don't get a ton of emails from those people, but I still don't usually reply to them. I reply to my students. But when I get emails from random, like, hey, we'd like to have 10 minutes of your time to tell you about this new product. I mean, maybe send me a video showing me what your product does, and then I'll watch that. I mean, I don't know. I don't usually click links anymore. But you could say, like, Google my product. You could say, like, hi, I know that links could always send viruses, so if you want to go to YouTube and see a product demonstration, just type this into YouTube, and you can check out our product demonstration. If you're interested in it, you know, just shoot me an email back here at this, and, you know, we'll talk. And you can also see our professional webpage, blah, 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 blah. We've been in business 10 years. I might actually look at that. And I'd maybe consider it, because I'm always trying to update what we do for our students and give you guys and gals and pals and everyone the best stuff. But I get reached out by a lot of people because they see like 1,400 students. They're like, ooh, we can just sell them this and have their students pay $50 each. I like free, though. I like free. A lot of what we do, like the Discord's pretty free. Hop on the Discord, say hey on the Discord. See if any questions on the Discord right now. We got some general chat. I'm here. There we go. Rain check. Discord's a little quiet today. It is open floor for questions. Your questions. We might do another chapter 4 question right here. I'll put a 1-minute timer on. If there's no questions, I will do another chapter 4. What questions do you have? We can talk about any of the topics we've been covering or do a future topic. I got a 1-minute timer, so Brian goes and takes a look at some chapter 4. Pokemon. I don't have it up right now. I was like, I can't play Pokemon. Got my Batman in my purple phone case. I might actually get a new phone case. I don't mind this being purple, but when I'm walking around playing Pokemon Go, it's got an open thing up here for the camera. And because of that, if it's ever raining, water gets in there. And this case is not so waterproof. I need to get the better one. We might be hopping back here. Let me get a good question right here. We did this one a while ago. It was a good quick one. We do some quick chapter 4 questions. I think we're gonna do it. 3, 2, 1. Let's do some quick chapter 4 questions. Here we go with some chapter 4. Let's check it out. Okay, so here we are. Which of the following is not necessarily an outlier? Oh, you got this. Imagine this was a test question. I'd love this as a test question. 50 points. Which one of these is not necessarily an outlier? I would love this as a test question. Which of these is not necessarily an outlier? And we can see it from problems we've been working previously where we had data. Where's a box plot? Ooh, that one shows differently. I'm pretty sure we have data that shows this. Yep. This answers the question to which one is not necessarily an outlier. And I'm just going to kind of do this. Which of these is not necessarily an outlier? Kind of obvious by how I'm showing this. If you look here, the maximum value in a data set right here does not have to be too far away. Imagine if you ask people, how many yachts do you own? And everyone's like 0. Well, then the maximum value is 0. The maximum value does not need to be an outlier. If it's not more than 1.5 IQRs above Q3, then it's not an outlier. So this is not necessarily an outlier. A number which is more than 1.5 IQRs from either end of the box plot, that's below Q3, or above Q3, below Q1, definitely an outlier. An extreme value that doesn't belong to the rest of the data, they're literally kind of giving the definition of an outlier. So this right here, just do some quickie questions right here, multiple choice stuff. That's a good test question right there. I like that. A student wants to determine whether or not a value in her data is an outlier. She calculates Q1, median, and Q3. Where is the upper fence? Ooh, I love this question. This is about as tough as we'd go on upper fence, lower fence questions. So this right here, take a moment. I'm gonna throw 100 points if anyone can figure this out. This is a great review question. Take a moment right now, see if you can figure this out. Make a little workspace for myself right here. There we go. Workspace on the screen, ready to go. So what do you need to do to calculate the upper fence? I believe so. If it's gender, that is correct. Yep, that is correct. Michaela, great question right there. You are correct. 50 points, Michaela. Thank you for swinging by and asking that. Yes. You know what? Send me a screenshot for me to double check, but thank you so much. Great question right there. We're actually doing some box plot stuff now. If you have more questions, let me know. Yep, put it on the x-axis. Who knows where this upper fence would be? I'll give you a hint. The upper fence is Q3 plus 1.5 IQRs. Ooh, people are getting it, I think. So the first thing you want to calculate is the IQR. The IQR right there is Q3, so the IQR equals Q3 minus Q1, which is equal to 10 minus 4, which is equal to 6. And then we go here and we plug in what Q3 was. Q3 was 10. We're just solving that above formula. 10 plus 1.5 times 6. Wait a minute, is it 6? There it is. And that is equal to 19. 19. Throwing 100 points. Thank you everyone for working this problem right here. And then Kayla, you're getting it. And so this was a really good practice right here. A good problem, probably about as difficult as we could go. We might even give you the numbers. But if you do the steps right here, you need to calculate what the IQR is and do this. Good short problem right there. Good practice problem. I like that one a lot. But just good practice. So the upper fence, which is where outliers would begin, is at 19. Watch it. Tell me I'm wrong. You better not. Yeah, tell me right. There we go. It's like I'm making an error. You never know. A student in an intro stats class calculates the upper fence in a box plot to be 15.2. Her maximum value is 17. Does she have an outlier? Good question right here. Yes or no? Take a moment. Oh, wrong music. Is this an outlier? You could DM it on Discord or email. Either one's fine. Always DM it on Discord, especially if you're posting an assignment. Don't post assignments in the chat. But I think you'd do that anyways. But just in case someone's like, "Here's my assignment," I'm like, "Oh, don't put it in the general chat." Pretty quick on Discord, and once I finish teaching, I start looking at emails. One time, someone emailed me. They're like, "I emailed you at 9 this morning, and you haven't emailed me back." And it was like 5, and I want to be like, "I've been teaching all day. I'm sorry." It was like at 5, and I was like, "I teach. I'm not always. I try to look at emails throughout the day." Is this an outlier, and why? Boom, Kayla right there on fire today. Most definitely yes, with the explanation earning those 50 points. Yes, this maximum value is an outlier. Yes, because it's above the upper fence. That person, the fence tells you where outliers begin, and this value is above the fence, the upper fence. Thus is an outlier. 100% with the explanation, understanding why things are outliers on box plots, because they're above or below the fences. And we have a fence of 1.5 IQRs above Q3, 1.5 IQRs below Q1. I think so, Tiffany. I think so. I think I looked over it, looking pretty good right there. See if we have any more multiple choice. Which of the following is a true statement about box plots? The center line on a box plot signifies the median. Let's get a box plot over here and look at this. Okay, here we go. Need a little help. Okay, that center line on the box plot signifies the median, and the answer to that is most definitely yes. That does signify the median. You can see right here, median, 4.36. Got it. Box plots are great for comparing 2 or more groups. Ooh. Box plots are great for comparing 2 or more groups. Definitely. The values which are displayed by a dot or an asterisk are outliers. Well, yeah, we don't have any outliers, so yes, they are. The center of a box plot is a box that shows the middle half of the data. Yep, look at that. Q3, Q1 is the middle half. Oh, we got everything right here. These are outliers right here, and sometimes you put an asterisk if it's more than 1. It's more than 3. Not a big fan of putting that on the test. Not everyone does that. People put asterisks for extreme outliers. Put dots for regular, and some people put asterisks for extreme. Here we go. Let's see right here. Let's go look at our data again to see. Okay, what did it say? When comparing the box plots of 2 or more groups, which of the following should be done? Compare the IQRs. Oh, this is good for Viz 3. So, okay, I sent you another email about the Viz 4 assignment. I think I have it now. I just want to share. Sure, awesome. I'll look at that here next. You got it. When we go to the break moment, we'll check it out. Compare the IQRs. Are they similar or different? Yeah, look at that. This one has a bigger IQR. So, League 1, this is League 1, has a bigger IQR. Yep, sure, do that. Compare the shape, for example. Are the box plots symmetric or skewed? Yeah, look, this one here is symmetric, mostly symmetric, and that one over there is skewed, a little to the right to the high on that tail. Tail's pulled out to the right. Compare the medians. Oh, yeah, median is higher for this one. Median's higher for this one. Check for possible outliers. There's no possible outliers. Boom. There we go. Gotta check that one. That's good stuff right there. That's what we should do, and that's what you should do on your visualization number 3 right here. Some Viz 3 help. And let's see if we had any others. Can I do drop-down menu here on this? Are there any other quickie ones we can do? Let me go towards the end of this. All of them, you got it. We're seeing if there's any other quick ones. We've done a lot of chapter 4 today. Good review of chapter 4. We did that one previously. Is this a quickie one? Oh, that's a long one. Come back and do it if someone wants. I think that's it for the short questions. These are good short ones at the end too. They're shorter. All right, it's got it. Let's go look at Tiffany's thing. Great job, everybody, right there. That was some quickie questions on chapter 4. Let me know your questions. We're going to look at, make sure Tiffany's things are 80s serious music right here. Okay, put a question in the chat if you got it. Questions in the chat if you got them. Let me see right here. Pivot. The one thing on your first graphic, Tiffany, I would maybe comment on trends you see where maybe males or females or having student loans, people who have student loans generally this, or people who don't have student loans generally have this. Do you see any trends in the data? It's pretty good. They'll probably give you full credit anyways. The biggest trend I see that blue bump right there. That is average credit hours by gender and if they're born in Tennessee. Oh, wow. What jumps out to me, they're all kind of similar, but the biggest outlier, the biggest standout in the data, and to make this clear, is the females that are not born in Tennessee. And that's interesting. Also, the females are higher than males. They're all kind of similar-esque, but the real difference in the data, and I'd maybe point that out, the real difference in the data is the females who are not born in Tennessee are really different than everyone else. That's interesting. I didn't know that. I don't know if that's a reason, but females not born in Tennessee have the highest average, which I think you say here. I'd mention it's the highest. You are quoting the numbers well. They'll probably get full credit for that. I would just maybe mention like a trend to say like, we see that females generally this, but talk a little bit more about the trend. Does that make sense, Tiffany? Like, I think you probably get full credit there, but you probably talk about the trend a little bit. Yep, we got some Viz 3. Let me drop that in the chat because we might not have enough time right now. Viz 3, I think we did yesterday morning. Try to do as many new things as we can. Thank you, everyone. We got 13 people watching. Thank you so much, everybody, right here. Let's get the morning video from yesterday. 103 views on the Pepsi presentation. So we had Pepsi come by last night and gave an amazing presentation with some great opportunities. What's up? Oh, what's up, everybody? What's up, Brian? Me having time for office hours never. William, good to see you here, William. Viz 3. Here's Viz 3 right here, and I'm going to drop the Viz 3, the visualization playlist in the chat. Visualization assignments. Me have time for sleep? Never. It's weird when you cut your hair and you're like, I don't even remember having long hair. What questions are there? What does Greek life mean exactly on the data? I think it's whether or not someone was in Greek life, yes, no. Like any sort of Greek life. We used to do like, is it social or is it like business? And then it's just like, are you in Greek life, yes, no. So it's multiple different things, but anyone who's in any sort of Greek life, whether it be like an honors or business or music or anything like that, because there's different types of Greek life, you know, like you could be in a more, not philanthropic, but more of a service Greek life. Is it gamma, sigma? Gamma? I don't know. But there's different types of Greek life. It just depends. Like some of them are much more like relative to a major or relative to social or relative to philanthropy. It just depends. Yep, in general, are they in Greek life? Great question right there, Kayla. Like a general, like, are you in Greek life? Yes, no. And then not specifying any sort of sub, like I'm in this type of Greek life. We actually used to do that in the data, and it got really complex. Yeah, just say like, if you're doing like your title, you could be like average GPA by born in Tennessee and Greek life. Just basically naming the variables. Great job, Kayla. Excellent work. I think a lot of people are getting ahead. It's just kind of jumping in, asking those questions. We are just chilling out at the moment. We've got enough time for at least a question or two more. I'm gonna go my chill music right here. If you have a question, let me know. If the music or anything's ever too loud, let me know. I'm always adjusting my levels. Always afraid I might be like kind of thinking, do I only need to talk about the difference in my second class? I would talk about the trend, like whenever you see like, if you have like different groups, be like, it's good to mention the numbers. Like perfect job right there. You can't even hear the music? Oh my gosh, have I not been playing music this whole time? When did I cut the music? No, the music should be going through. Can you hear the music now? It shows my meter's jumping on it. I always wanted to be a little subtle. Yeah, I'm like double. Good. I was looking at my meters on it because I can see my meters. Like here, wait. You want to see some inception of what's going on right here? I'll show you inception. So here's let's see, world inception. This is what I see right here. These are, if anyone likes OBS, these are all my different scenes right here. And this is like what's in this scene. So I've got all these different things here, whether I want to pull up like Puppet Shark or all the different things if I want to like close this back down. But this is tons and tons of time getting everything set up right here so I can just click buttons and make my life easier. But that's the inside world of what I see when I'm streaming. I see all the selections and meters and stuff. It is really low. Good. Yeah, I kind of want it. That's kind of my goal. If you ever want it to be louder, if you're like, hey Brian, I think it'd be louder. I always want it to be like a nice like chill in the background type thing. I never want it to be like overpowering my voice. Just a light soundtrack to life. That's the way it goes. Like, oh, thank you so much, Kayla. I appreciate that. Makes it easy. It makes it nice so we can do like, you know, our fun effects. Still, I don't care how much I overuse it. Still one of my favorite things that I did. Maybe I should have the background more bright. Well, thank you so much, William. I appreciate that. There's effects I don't even use that I spent like hours working on. Like hours and hours working on effects, not even use them. Yep, let me take a look at that chart on Viz 4. I broke my stream with this yesterday. Let me take a look at the scale because it's not that much different. Yeah, it's really not. You could mention that. You could say like, I would say that, Tiffany, like you're saying like on the second visualization, I noticed how it was like 15.8. You could just mention there that the highest group is this, but in terms, everyone's taking about 15 hours. So I would say that, Tiffany, like just talk about like the trend. Like you could say this, like a trend we see in this data is this. Like that's a good sense to start. Like a trend I see in the data is this, that females who are not from Tennessee have the highest amount, but even though they are slightly higher, they're still in the 15 range. This is not a very large difference, but it is worth noting that they are the highest group. Does that make sense right there? Just never hurts to add a little bit more on. As long as you don't say something wrong, like where the graders are like, ooh, that's just not something we would like, just doesn't make sense. As long as you don't say something wrong, the graders are not going to take off points. It has to be like really wrong. You just have to like massively be interpreting the data wrong. And then the graders could take off points. I'm really glad people like this. I've got a lot of different things to fix. I've got to fix some buttons on my Stream Deck. I fixed a few. I have so many buttons. So many buttons. Is today Wednesday? We didn't even do Wacky Wednesdays. How did we not do that? I wrote this, a trend we see is females that are not born in Tennessee are more likely to take, on average, have a higher average. I wouldn't say are more likely. I know, right, William? I wouldn't say, you could say on average have higher. I would say the females not born in Tennessee show the highest average. They are the most different from all groups. That should be enough right there. Thank you, William, right there. I appreciate that. I want people to miss this class. I want people to like, I don't know. It means a lot to me if I see someone on campus and they're like, hey, I had your class 2 years ago. It was so much fun. I'm like, oh, that's great. Do you remember anything? They're like, Wacky Wednesday. No, like, don't worry. I want people to have fun. I want people to remember the fun. I want people to remember the material. No, it's just, sometimes I have people, what's up, Harper? Good to see you here, Harper. I've been on the strip before and I'll just be walking and someone will be like, QQ, straighten up. No outliers, plot doesn't thicken. And I'll be like, what does that mean? They'll say, I don't know. Like, it's the conditions for regression. So that cracks me up. And then I think by telling people that has happened, it's happened like 3 times now where someone's been like, QQ, straighten up, no outliers. Yeah, that's our goal, Kayla. We've got a lot of, a few people, Eric Kelly, I think in finance does something of like what I do. And actually, I've got this and I never use this. Let me show you something I have that I don't use. And you can tell me, hey, Brian, you should use that more. I've got it set up. I just forget I have this. Let's give it a shot right here. Try something new. Oh, thank you so much, Kayla, right there. This is my Khan Academy screen, which I rarely use. But we could go over here and I could draw normal curves and everything. I got to get used to being on the screen with it. But if you ever wanted, we could, and I could try to start using this more. But Eric Kelly in the finance department helped me set up my Khan Academy screen right here so I could start doing this more often. I just forget I have these and I don't use them nearly enough. But we took some time and we set up kind of a Khan Academy screen. So if you're like, hey, Brian, you should really start using this more. Yeah. And I would like to get other instructors kind of doing what I'm doing. There's a lot of time and a lot of buy-in. And I'm very lucky because I started teaching online 7-8 years ago now. Started teaching online a while ago, but this is pretty nice. Everyone's done a highlight on it. Ooh, works quite well. A term we see is females that are not born in Tennessee in the state of Tennessee average more credit hours than females that are born in Tennessee. How about this? Yeah. You could say that's the biggest gap. Yo, good to see you here, Adam. Checking out the Khan Academy screen right here. Gotta make my Mario effect too. Khan Academy screen. Thank you to Dr. Eric Kelly, I believe in finance, who came up with this idea. He's also the reason we have the timer on the start screen. He showed me that. So I think the biggest thing is, and this is my advice to any educator, you have to find your own voice. I think we all kind of know that in life, but no one should, I mean, like, people can copy what I do. I'm fine with that. But if you copy someone, it's not really you. If you take what someone does and you translate it into your voice, then that's where the magic happens. So, I think Eric Kelly's done that 100%. Like, technically, I'm copying him to some degree now. Like, he showed me the Khan Academy thing, and I just haven't worked it into my style yet to hop over to it. So, I'm kind of copying him now, but I'm trying to work it into my style. And, like, the timer I use is the snaz timer, which he found, and I had seen, but he showed me how to use it, basically. So, whenever you see those countdowns at the start of class, which is new this semester, just making sure, yeah, it looks great. I think you're good, Tiffany. Excellent work. And when you see those countdowns at the start of class, I'm actually inputting the time. If I was in your time zone, I could make it count down to the right time. Or if you tell me how to fix the thing here so that it, yeah. I don't know how to fix it so I can fix it to your time. I wish I could. But I'm in a different time zone, so it'd be 1 hour different on it. I don't want to be like, oh, it's just always 1 hour off. It's confusing. So I just do a countdown, but I have to look at my phone, I have to see how much time. It's not too bad. Just get it set up each time. Automation is better, though. But I really appreciate all the positivity. If you like what we're doing here, always just share it. Let people know. The positivity really helps me, really helps other people. Really helps everything. What chapter's on the first exam? Great question. Check this out. Watch Mubot is going to tell us. Great way to end class. Let's talk about that first end office hours. Let's talk about that first exam. Mubot, tell us where we can find data on that first, or info on that first exam. Mubot's going to tell us where to go. Oh, I think it's review 1. I don't know how to talk to Mubot anymore. Review 1. So Mubot's going to tell us about the Stats 1 webpage right here and where to go. Mubot, where you at? Go here for test 1 review. Let's go there. And here we go. One of the many commands Mubot knows is how to go to Stat 1 review. Now I'm going to add the videos below. I don't know why we lost our videos. So here are, I'm going to maybe make this look a little bit better right here. We need some formatting on this page. Got to make it look all pretty. Any other R classes and data can be recommend? Any visualizations? We love visualizations. Pepsi was talking about that last night, like telling stories with data. So visualizations. ggplot too. Here's the topics. It's going to be crazy huge. We are going through chapter 6. Whoa, what? We're almost there. We're almost there. Think where we're at. Look at pivot. You remember how I said like pivot table today? I was like, there's not that much to cover. There's not that much to cover. This is everything you need to know. Recommendations, chart titles, axis titles, data tables. Being able to recognize unusual information in a pivot table, basically being able to read pivot tables. Reading pivot tables into Excel, they have the same data format, and here's where things get difficult. These are going to be more difficult chapters right here. So if you notice, we've done all this right here. Chapter 1, Chapter 2, Chapter 3, Chapter 4. We did a little bit of this today. We'll go over it more traditional next class. So if you're in the later today class, you'll see that. And then here's where things get scary, which we also covered this during office hours today. Work on that data camp. You got it. And then here's Chapter 6. Chapter 6 actually is probably easier than Chapter 5. I mean this, you really want to get a great grade on Test 1. Test 1's a great opportunity to get a great grade, but here's what stands in your way of a great grade. This. Moreover, this right here, Chapter 5. Chapter 5 is going to be the chapter where people just say, I don't know how to do it. Whatever. I'll just make a bad grade on that portion. It's not the end of the world if that happens, but there's difficult chapters in this class. And Chapter 5 is probably one of those ones that is people's first stumbling block. So, if you are stuck on this, and I don't know why we don't have the videos, I just need to update the playlist. Maybe that's why Terry didn't put it in here yet, because I haven't updated the playlist. Let me go grab the playlist on this, and I'll need to go update it. I need to put that on my board of things to do. So let's go here to playlists, and I've got a bunch of Exam 1 playlists. Oh, see, I can't even find them. Test 1 playlist? Test 1 speedruns. Oh my gosh. If you want to go over the topics on the test, I would highly suggest doing speedruns right here. Speedruns cover many of the topics. If you notice, I have through 7 and 8, which are not on this test, so I need to update this. We're always updating things. So you can see right here, this is Test 1 speedruns, and you can go over and watch them. You can go over summarizing data, and I do the full chapter right here, going over everything.
Speedruns of statistics. Brian Stevens versus Chapter 2, displaying and summarizing data. Begin.
The first thing we want to do is understand the range. And the range is simply the maximum value minus... If you want R squared is down here in Chapter 7. So, what is R squared? What? We're gonna hop back and hear the questions. Guess what? It's going back to speedrunning these questions here. How do you interpret the y-intercept? This is when we're still in the studio. Even though r squared is not r, so r is not r squared. It's a very basic speed run. If you want a much longer speed run of it, what is the actual value? Well, the actual value would just be my actual height. See. So we predicted that I should go in and put all the topics marked in here. But just and then by the slope of the line. Oh, look where we're at. Look where we're at. So interpreting r and r squared, or r and r squared, interpreting r squared right here. So there you go. Past and future Brian in one video right here. But check this out. We have r and r squared. So if you want to do a speed run of remembering r squared, this is the video to go towards. And we're looking at some residuals right there. Where my space pens go? I lost my space pens. But check out these videos right here. That's some of my biggest advice right here. Tiffany, great job on those points right there. Keep earning those points. Keep earning those points. You can get up to 1.2 on your total average. And you can see people are just like, you can see it gets slower. So the last few points are going to be a long way. But if you're already at that much, you might get to the big 1.2 bonus. But great job right there. You can see people are slowly. I love it. Everyone has a different amount. Mark, Randy, and Kayla, and everyone has different amounts of points. William right there with 50 hours. That's so awesome, William. I love it. I love seeing that. Mubot loves it too. Mubot says thank you.
I can say thank you for myself, Brian. Puppet Shark, how are you doing? You know what this means? It's time for the end of class, everybody. Class is over. Office hours is over. It's time for Brian to go. As Brian likes to say, bye for now, everyone. Bye. Bye. Bye, everybody.